Hey everyone, today we're looking at rational functions, and we're going to go ahead and continue from what we missed out on last time. So I know that in the last lesson, which is the one that I taught in person, if you didn't get a chance, watch the video from before so you can catch up. But let's see, we did this right here. Oops, we did these right here for the last class, and then today what we're looking at is this right here. We're looking at slant asymptotes and then how to model and solve real life problems. Well, really, just how to use slant asymptotes that we're going to be looking at for today. So I added a cheat sheet onto the notes here today. And I also added it onto the Google Drive. If you want to print this cheat sheet right here, it's titled, let me see. I titled it Asymptotes Cheat Sheet. If you want to print that out before next week's quiz, you're free to do so. And then you can go ahead and we're taking the quiz next week, early next week, so either Monday or Tuesday, depending on what day. Nope, sorry, not Monday. Tuesday and Wednesday. You know what? Let's do Wednesday, Thursday. We'll take a quiz on Wednesday, Thursday next week, depending on the schedule and what day I see you guys. Just make sure that you know that the quiz will be on Wednesday or Thursday next week. Okay, so let's start off by looking at this right here. What is an asymptote? An asymptote is a line that the graph of the function approaches. So by now, hopefully we know this right here. It's a line that the graph of the function approaches. Something that's important is that there are different aspects to rational functions besides the asymptote. We also have holes. And in order to find asymptotes, functions must first be reduced. We see that in this example right here. F of x is equal to x minus 2 divided by x squared minus 4. I have to first factor this out, and we've seen this before already in class. When I factor that out, I cancel these two out, and I'm left with 1 over x plus 2. This means that the graph of f of x has a hole when x is equal to 2. So we have a hole when x is equal to 2 because we're saying x minus 2, which would have been equal to 0, gets canceled out, and now we're left with this right here, but the value that got canceled out would have been the hole now. The graphs of f of x equals x minus 2 over x squared minus 4, and y is equal to 1 over x plus 2 are exactly the same except for the hole when x equals 2. If I gave you these two, they would be the exact same, except for the fact that this one would have a hole, and this one would not have a hole, because there's nothing that I can reduce it with. Graphic calculators will not show the hole in the first graph, but the table will show an error when x is equal to 2. If you have a calculator, you're free to check that, and it shows up on the table itself. Vertical asymptotes, we saw this last class. I just want to go over one or two problems in the examples here. Like I said, you can print this out and use this during a quiz. For vertical asymptotes, the way that we're going to find them is that we first have to factor the top and the bottom, see if we can reduce anything, and then go from there. If I'm looking at the same problem from earlier, I think it was the same problem. Actually, no, we did this problem in class. 1 over x squared minus 4. What can x not be equal to? What can the denominator... Let me use a pen. What can the denominator not be equal to? It cannot be equal to 0. So if we know that, then we should ask ourselves, well, the domain can be anything, right? But it cannot be equal to 0. So x squared minus 4 cannot be equal to 0. Even if I move things around, it would still work out the exact same way. X squared is equal to, or not equal to, 4. What's the square root of 4? Square root of 4, or square root of both sides, would end up telling me that x cannot be equal to plus or minus 4. So I have, not plus or minus 4, plus or minus 2. That's why I have this value right here. We're saying that the asymptotes are at x equals plus or minus 2, but we also know that the domain cannot be plus or minus 2. So the graph of g of x has the vertical asymptotes at negative 2 and at 2. And when we graph this, there's a line right here at negative 2, and then there's a vertical asymptote here at 2, positive 2. All right, so that's the main thing. I guess we could double check for horizontal asymptotes for this one, but we'll come back to that in just a second. There's different cases for horizontal asymptotes. So if we said that if the degree on the top is higher than the degree on the bottom, they will not be a horizontal asymptote. If the degree on the top part is equal to the degree in the bottom, here we have a degree of 1 and a degree of 1, it's written in a way that's not in the correct manner, then I know that what I'm going to end up having is the leading term over the leading term, and that gives me negative 2. So now I know that I have a horizontal asymptote at y is equal to negative 2. And we see that on this line right here. The other scenario is when the degree in the numerator is higher than degree, it's lower and is equal to k, and is less than k. In that case, we know that we have a horizontal asymptote at y equals 0. So that's why we have a line here at y equals 0. Let's go back to this one real quick. We have a degree of x to the 0. So n is actually less than k. Do we have a horizontal asymptote? We do. And you should know that we have it at y is equal to 0. Because we said that in this case down here, the horizontal asymptote is at y equals 0. And therefore, even though it's not graphed on here, you would have seen one right there, the horizontal asymptote. All right, so now let's look at slant asymptotes. Do they have any cases? That's unfortunate. The cheat sheet does not include them, but we're gonna look at them anyways. So, when do slant asymptotes occur? They occur. Let me get this correct. They occur when the degree in, let's call it the n of x, your numerator, the function in the numerator, is 1 more. In other words, the degree of n is 1 more. Actually, let me erase this first. It's 1 more than the degree on the denominator, your d of x. In other words, if the numerator's degree, n, is 1 more than the one in the bottom, your k, that's when we know that we have a slant asymptote. If I'm looking at this one right here, the very first one, first thing I should try to do is ask myself a few questions, but one of those questions would be, is there a horizontal asymptote, a vertical, and a slant asymptote? What I see here is that the x squared is 1 more than the degree on the bottom. In order for me to find the slant asymptote, I'm going to have to do a couple things, but I'll get to that in just a second. Let me look at the other stuff first. Let me factor out an x minus 1 over x plus 1. All right, so do I have any holes? Nope. Do I have any vertical asymptotes? Yes, I do, and it's at x equals negative 1. Do I have any horizontal asymptotes? Let's go look at the rules again. Do I have any horizontal asymptotes? If the n is greater than k, I do not. So therefore, let me go back to the problem. None. I should write holes as none instead, because then that way people don't think I'm saying there's a hole at x. Horizontal asymptotes, none. But we did say that the degree here is 1 more than the degree in the denominator. So how do I find the equation of a slant? Everything else has been easy. I mean, you can graph x equals negative 1, right? Negative 1, and then I'm going to draw my dotted line here for my asymptote. That's easy to graph because it's just a simple equation. It's just x equals 1. But in order to find the slant, I'm going to have to divide. So I'm going to say x plus 1. And it looks like long division has not escaped us. You know what? Let's not use long division. I'll use long division on the filled in notes if you want to see that version. But for now, because my a value here is just 1, I'm just going to use synthetic division. So I have an x squared. The coefficient is 1, negative 1. And don't forget your placeholder of 0 here. 1, negative 1. Negative 2, negative 2, negative 2. This would have been the x squared, so this would be x, negative 2, and I have a remainder of negative 2. In the past, I would have said, okay, so normally I would have said that this remainder is an issue. But here, I actually don't care about my remainder. All I care about is this equation right there. That is going to be the equation for the slant asymptote. All right, so that's the equation. How do I write that equation? I'm going to write that as y is equal, let me write it over here actually. So slant asymptote. Damn. Y is equal to 1x minus 2. Let's see, do I have any other information for this? Oh yeah, well yeah, y equals x minus 2. How do I graph that though? So I have 1, 2, 1, 2, 1, 2, 1, 2, 3, 4. Alright, so the way that I'm going to graph this is I'm going to just graph literally this equation right here. Y equals x minus 2. I have a point at negative 2. I go up 1 over 1. Up 1 over 1. Up 1 over 1. Alright, and then we get the idea. So that is my slant asymptote. From here, I can very easily graph everything else. I'm just going to plug in a couple random points. Let's plug in a value that's on the left side of the asymptote. And I'm going to plug in, use a different color, f of, I don't know, negative 2. If I plug in f of negative 2, I end up with negative 6. If I plug in f of, now we're going to plug in another value. We're going to plug in a value that's on the right side of the vertical asymptote. And I'm going to plug in f of 0. I'm going to plug in f of 0. I end up with, oh, there you go, 0. It cancels out the top because that means that I would have 0 and 0. And that gives me a numerator of 0 over 1, which is just 0. All right, so now we've got two different points. We've got one at a negative 2, negative 6. 1, 2, 3, 4, 5, 6. And then we said it's at negative 2. And then we also have another one at 0, 0. All right, so what does this look like exactly? If you plugged in more points, it would give you a better impression of what this looks like. But you also have to have a basic understanding of what a rational function looks like. This line right here is going to either move left or right. As it's moving to the left, it can't touch the asymptote, so it's going to start to bend towards it. As it goes to the right, same thing here. It can't touch the asymptote, so it's going to go down. This one up here can only go left or right. And as it's going left, it's going to start to curve, and it's going to go towards the asymptote. Over here, this one is going to curve also and almost go right next to the asymptote. And so we have that right there. Let's do one more, just for further practice. Actually, let's do two more. This one right here, same thing. I'm going to go ahead and factor this out. I have x, what is that? I have x, factors of negative 2 that give me negative 1 are negative 2 and 1. So x plus 1, and then we have x minus 2 all over x minus 1. That should be it, right? Yeah. Okay. Do I have any holes in here? I do not. Do I have any vertical asymptotes? I do. I have a vertical asymptote at x equals 1. And then look at the degrees here. I have a degree of 2 and a degree of 1. Therefore, since the degree in the numerator is 1 higher than the degree in the denominator, I know that I'm going to have a slant. And the slant is at, how do we find that one? We're going to have to do division. So let me use a different color. 1, 1, negative 1, negative 2. Remember, I don't really care about this value because it's going to be the remainder. All I care about is this right here. This would have been the x squared, right? So that means that this is 1x. So my slant, by definition, is just whatever's in here, and that's a y equals x. You could say y equals x plus 0, but that doesn't really matter. That's just redundant. Now we have to find him. We have to graph this real quick. I know that when I have y equals x, that's just a diagonal line. I have 1. Like that. Okay, and then we also have another one at x equals 1. The last thing I need to do is plug in points. F of 0 is equal to, that's going to give me negative 2 times 1 over negative 1, which is just 2. I plug in f of 2, that's equal to 0 over 1, which is just 0. Let me plug in a couple other options, just so that you can see what I'm trying to do here. F of, we could do f of negative 1, and that would give me negative 1 plus 1 is 0, times that is 0 over 1, and I'd end up with 0. Yeah, perfect. And then I guess another option, well, that's pretty much it. That's all I really care about. So 0, comma 2, I've got a point here. 2, comma 0, I have a point there. And then at negative 1, 0, I said that I have another point. If you need more points, you just feel free to graph them. But I know that this is going to approach that point. It's going to go through that point, and it's going to go through that and look like that. And then lastly, my other point, it's going to look very similar, just like that. And that's pretty much it. That is the graph for that one.
All right, here's one last one. I'll show you the screen. What I want you to do is I want you to figure out the horizontal asymptote for this one, any vertical asymptote, slant, and any holes if there are any.